Hello friends, today we will see the unit number 5, friction. And before going to the numerical of this chapter, we should know the basic concept regarding the friction. So comes to the first window. What is meant by friction? So a resistance to the motion of any body when we apply the external force is nothing but the friction. Here the definition also as mentioned, when the body slides or tends to slide on surface and on which it is resisting, means that surface if resisting to the motion of that body, then that resisting force is nothing but the friction. So simple diagram has mentioned here. One mass or the body consider here, which is having the W weight, and if we place that body onto the surface, okay, so body is having the W weight, so always the weight will act in a downward direction, so this will be the W arrow. And if you apply the force, if F force in this direction or the P force in this direction from left to the right, then the friction will generate into the opposite direction. So this is the push type of the force. If we consider the pull type of force here, then what will pull type means will look in this way. So due to the pulling forces, again the friction will be in the opposite directions of that force. So in this direction, consider this pulling force as a P, and the friction force indicated by the F. So this will be the normal. But one thing you should remember always, when according to the Newton's law, equal and opposite reactions, when you put the body onto the surface, so due to the W weight, the surface also will show the reaction force, and that reaction force will be in the opposite directions of this W weight. So that will be in a upward direction, and that reaction force or the normal reaction force will be indicated by the R later. So I think you got the whole idea about this diagram. So always remember this kind of the concept, because it will be the useful to solve the numerical. So the weight W body will act in a downward direction, then pulling force, if you apply P, then the reaction of friction force will be act in the opposite directions of the P, and that will indicate by the F. And due to the W weight, the reaction or normal reaction force will act, but that will also force in a opposite direction, so in upward direction. So this is indicated by the R later. Now another thing is, so friction F means friction, and the formula for the friction is F is equal to mu into R. So now we know R is the normal reaction force and mu is the coefficient of friction. Always remember, coefficient of friction means mu, and F is the friction. Clear? Okay, come to the next window, limiting friction. So if we are applying the force on a body, if the body will move when we apply the force of 20 Newton, the body will move from A point to B point when we apply the load of force 20 Newton. This is the condition, means the body can move when we apply the 20 Newton force. So this is the minimum value to start the motion of the body. Means if I apply the 19 Newton load, then the body will not move. Is it? The body will not move, because the maximum capacity of that body to move is the 20 Newton. So at the 90 Newton value, the body will not move from its original position, from its initial position. So we have to apply always to get the motion 20 Newton. So this 20 Newton value is nothing but the limiting value, because at this moment we are considering the P is equal to F, means whatever the friction is having the 20 value, and that will be equal to the applied force. So when we cross this type of value, or it is the value where the body will try to move. Here the definition also has mentioned the maximum friction force that can be developed at the contact surface when the body just on the point of moving. Body just on the point of moving means at the 20 value or beyond the 20 value the body will start moving. So at the 20 value, if the body start moving, then that value is nothing but the limiting friction. That value is nothing but the limiting friction. Now comes to the second window, types of friction. Again, two types of frictions are possible. One is static friction and second is the dynamic friction. If the body is in a rest position, in a rest condition, body is not moving, only placed at the one place. If the book is placed on the surface, then it's an example of the static friction. Some kind of the friction is possible in the case if the body is not moving also. Clear? So the friction experienced by body when it is at the rest is nothing but the static friction. Dynamic means if the body is in the motion. Now take the example of the vehicle. If the car is not moving, if the car is at the one place, and then that will be the static friction. If the car start move, then in that case we will consider the dynamic friction, because whatever the friction will generate due to the motions of that vehicle tires, then that will be the dynamic friction. Under the dynamic friction, two subtypes comes. So the first is sliding friction, because this type of the friction also comes under the motion, sliding friction, and second is the rolling friction. So this definition is simple: friction experienced by body if the body is sliding. Consider the examples of the cream biscuit, the one biscuit and second, and in between there is the cream. Okay, when we remove the first biscuit, then it's make the some kind of the sliding motion. So the friction will generate because it is not easy to remove that one biscuit from the another in a easy way. You have to apply the certain forces there to remove that one biscuit. So that type of the friction is nothing but the sliding friction. Second is rolling friction. If the ball is rolling onto the surface, then it will be the rolling type of friction. Come to the second. This body is in the rest condition, and in that case the whatever the force applied by you or the external forces or the air, and the same force will be acted by the friction. So this will be the frictional force, this will be the applied force, and this will be the frictional force. But when the body is in the rest condition, that force is nothing but the static friction. The second is the sliding friction. The body is sliding onto the surface, so whatever the resistance will be generated into between the body and the surface is nothing but the sliding friction. Then the second is rolling friction. If this body is rolling over the surface, so whatever the resistance generated by the surface and the body, this will be the rolling friction. Come to next, angle of friction. So angle of friction means in a simple format we all know that formula F is equal to mu into R. So angle of friction, so take rearrange these equations. So mu is equal to F by R, means the coefficient of friction is the ratio of frictional force upon normal reaction, and the angle of response or the angle of friction is proportional or equal to the coefficient of friction. Means we can say the phi, actually the angle of friction indicated by the phi value, phi like this. So phi will be equal to the coefficient of friction. So if the phi is equal to the coefficient of friction, then directly we can consider that phi is equal to F by R. We can consider according to this formula, phi is equal to mu is equal to F by r, so phi is equal to F by r. So we can say the coefficient of friction is nothing but the ratio of the frictional force and the normal reaction Okay, comes to the next window, coefficient of friction. Again the same as I said before, n is nothing but the r. Normal reaction indicated by the n or the r later. Now the angle of response. Now consider the one body which is placed on the surface, and if we try to incline that surface by a certain angle, is it? So consider the body here. Instead of that, if you try to incline this surface by a certain angle, then at the specific value the body will try to slide on that surface. So whatever the value at which the body starts sliding, that value of the angle is nothing but the angle of response, is it? With the increase in angle of inclined surface, the maximum angle at which, so main thing is maximum angle at which the body starts sliding down, the called as the angle of friction. Okay, then next is laws of friction. We have already seen in unit test 2. Laws of friction, static friction and dynamic frictions related laws are present. So these are the static related laws. In that, so if the body is here, whatever the P we are applying, equal to that P value, the frictional force will generate. So that will be F, frictional force indicated by F. So we can write here the P is equal to F, means if you are applying the 20 force, then the frictional force generate also will be 20. So P equal to F. Friction force always act in the direction but opposite to that which body tends to move. Okay, opposite to this P, the frictional force will act. Then second is both the value will be equal. Third is the ratio of limiting friction and normal reaction is constant, means if the mu is having value 0.2, then and if you take the value of F by N or F by R, then the value of this also will be 0.2. Okay, the friction force doesn't depend upon the area of contact between two surfaces. So how much area is there, on the basis the friction is not depending. Actually the material which is present there in between the surface and the body, on the basis the friction force is depend. Now next, laws of dynamic friction. So dynamic friction, so the first condition, laws of static friction, was related to the rest body, and second is laws of dynamic friction. Now friction force always acts in a direction the same as like the friction law, static friction law. The friction always act in the direction opposite. Then the ratio of limiting friction and normal reaction is constant, again the same as like the static. And for the moderate speed the friction force remains constant, but with the increase in the speed the friction will slightly decreases. This is the important thing here. Only the new point is the third one, otherwise all 2 points are same as like the laws of static friction. Now comes to the conclusion. In that unit we have seen the what is meant by the friction, then the types of friction, statics and dynamic friction, and under the dynamic friction, the rolling frictions and the sliding friction. We have seen the formula for the friction, F is equal to mu into R, and if you rearrange this equation, then mu is equal to F by R. So according to the one proved theory, we can call it as a phi is equal to mu, means the angle of friction is equal to the coefficient of friction is equal to F by R. So we can define the angle of friction in a different way. Angle of friction is the ratio of force of friction to the normal reaction. So this is all about the friction chapter. Thank you.